welcome to Calculus for Us. In this video we will be carrying on from our previous video about integration. However, this time we will come across questions that involve us finding the area underneath the curve. Okay, just as a reminder, this is the basic rule for integration. You have to always use this pretty much to integrate. In this case, we forget about the plus c. In the last video I said to never forget the plus c, because you will lose marks, but in this video we will just forget about the plus c because we don't really need it. And we will understand why in a minute. Okay. So here we are, this is our first question. I've got two questions here, one of them is harder than the other. This is the easier one, this is as basic as it will ever get with these type of questions. So, in this question, we're given a graph, we're given a curve. I've taken away part B because it has nothing to do with this topic of this video, so I've removed it, and I've only kept the integration part of that question. So, we've got a curve, we're told it begins from the origin, it hits point B on the x-axis, and we are given the equation of the curve. Hope you can see it. It's relatively small. I'm just going to rewrite it. So it's y is equal to 3x to the power of a half minus x to the power of 3/2. Hopefully you can be able to see this much better. Okay, so after we're given the equation of the curve, we're given the curve itself on the graph, and then we're told find the x-coordinate of B, or we'll show that it is 3. Prove that it is equal to 3. And so what we have to do here, well, as we can tell from the graph, that where it is equal to B, basically y is equal to 0. So we do y is equal to 0, so we have 0 is equal to 3x to the power of a half, minus x to the power of 3/2. We will factorize this, so we can take out x is equal to x to the power of a half. So let's do this. We get 3 minus x, okay, equal to 0, and so looking at this is equal to 0, or this is equal to 0. And so from this we can tell that the point B will be equal to 3. Okay, now that we've established that, we've done part A, let's go to part C. As I said before, part B had nothing to do with integration, so I just removed it. So part C is the part that we are actually going to concentrate on in this video, because that is the part that will allow us to find the area underneath the curve. So we know that, let's say this is point this is our A and this is our B, okay, because integration you are given, so if I was to rewrite this, would pretty much be, so find the area underneath this curve with with B and A, or in this case B is equal to 3 and A is equal to 0, and then you'd be told this is your function. The function for this curve is this. Find that. Because of lack of space we've got left, I'm going to do it on a new page, but I will rewrite down the equation of the curve on that new page. Okay, there we go. Okay, so our equation, as we know, is y is equal to 3x to the power of a half minus x to the power of 3/2. Okay, the first step to finding the area under the curve would be to integrate this. Okay, so let's integrate this, and well, you should be able to know how to do this from the previous video, so integrating it, it will give us 2x to the power of 3 over 2 minus 2 over 5 x to the power of 5 over 2. Okay, so this is now our integrated function. Okay, now in this question, if you look at the question, when they tell you to find the area underneath and they give you your boundaries, so A and B, what you have to do is you have to, after integrating, put in A, well, put in B, and then after you've put in B, you do minus, and then you put in A. So we're going to do that right here. Okay, so we do 2, so just to remind you, our B is equal to 3 and A is equal to 0. So we do begin with B first, and then we go to A. So we do 2, open brackets, 3, close brackets, the power of 3 over 2, minus 2 over 5, open brackets, 3, to the power of 5 over 2. There we go, 5 over 2. And then we put them into these big brackets, and we do minus, open up our very big bracket, and then we do 2 to the open brackets 0 to the power of 3 over 2 minus 2 over 5 open brackets 0 to the power of 5 over 2 close brackets. Okay, now we know, straight away this will equal to 0. But if it didn't, if it wasn't 0, then what you could just do, put the whole thing into your calculator and it should give you the answer. Or do it one by one. And then you should give you the answer as well. Okay, so now that we know this is equal to 0, let's do this one. Doing this one, we will get, well, after doing on your calculator, you should obtain the value 12 over 5 root 3. That is the final value that you should get. So, in other words, the area underneath this curve right here is equal to 12 over 5 root 3. Okay, so now that we know how to find the area underneath a curve using integration, okay, let's do a bit of a harder question. Okay, so this is the harder question. In this bit, these kind of questions, there's a bit of a trick you can actually do. Rather than finding individually the area underneath a straight line between A and B, and then the area of the curve between A and B, and then take them away from each other, what you could do is you could equate the equations if you are given these equations, which you will be given them. So you just equate them, and whatever you get, you integrate that, and then you do the whole, so you plug in B, and you do minus, plug in A, and then you put all that into your calculator, and then you should get this area right here. Okay, so that's a bit of a simpler method if you want, so let's do it. Okay, so what does part A say? Part A says calculate the coordinates of A and the coordinates of B. So they haven't given us A and B, so we'll do that ourselves. Very basic. We're told the equation for the straight line is y is equal to 9 minus x, and the equation for the curve is equal to y is equal to x squared minus 2x plus 3. So what we have to do to find A and B, because they intersect at those points, we just have to equate them. So we do x squared minus 2x plus 3 is equal to 9 minus x. Okay? Now to simplify this, we get x squared minus x minus 6 is equal to 0. Now we have to just factorize this. Do x there, and x there, and we will get those values. Okay, equal to 0. So this is equal to 0, that's equal to 0, and we will understand that x is equal to -2 or +3. Just plug those right in to either one of your equations. I'll go for the straight line equation, it's just way easier. So to 9 minus -2, which will give us 11, then 3, so we do 9 minus 3, which will give me 6. Okay, so we know the coordinates of A will be -2, +11, and the coordinates of B will be equal to +3 and +6. Okay, so now that we've done part A, let's go on to part B. Well, part B says the shaded region R is bounded by the line and the curve. Calculate the area R. Okay, that's our area R. As I said previously, this is a very simple method you could use. Just equate them, equate the equation of the straight line and the equation of the curve, and then integrate that rather than integrating individually the curve and then the line and then taking them away from each other to find the area in between. So let's do that on a new page. Okay, there we go. Just to remind you here, so A would be, coordinates of A would be -2 and 11, and here, and the coordinates of B would be 3 and +6. Okay, so part B. The same thing that we did in the previous question that we did, the first question. Okay, because of the first part of the question, we've already kind of equated them and we found out what that is equal to. So let's just jump on and do that. Okay, go. So after equating them, we know they will be equal to x squared minus x minus 6. Okay, so integrate this now with, so if I'll just write it up a bit more neatly, here we'd get here, so 3 and -2, okay, dx. There we go. Now integrate this with these two boundaries. Integrating it, and you should know how to integrate this. By any means, feel free to stop the video and attempt this yourself and then come back and see what the answer is. So integrating this, we will get x to the power of 3/3 minus x squared to the power of 2, x to the power of 2/2 minus 6x. Okay, we've integrated this. Now just plug in b, which is in this case 3, and then minus, and do minus, then plug in a, which is -2. Okay, so I'll do that here. We've got 3/3 minus 3 squared over 2 minus 6 multiplied by 3, big brackets, minus, another big bracket, then we'll do -2 power of 3/3 minus -2 squared over 2 minus 6 multiplied by -2. Close big brackets. Okay? Now, put all of that into your calculator and you should, so if I was to put each individual one into my calculator, because sometimes they'll be just way too long for you to be able to put them into the calculator. So you can put them individually. So putting them individually in, we will get, by the way, you will get negative results here, so it's okay, but just do the maths, and then when you're done, and there's still a negative, just forget about the negative. because this is an area. Area can't be negative. So we'll get negative 27 over 2. Negative. That's the negative over there. So let's put it into brackets like this. Maybe it's a bit easier. You get 22 over 3. Okay? Do the math. So the negative 27 over 2, negative 22 over 3, they will pretty much add because they're both negatives. So you'll end up with a negative 125 over 6. Okay? This over here is our final answer, okay? You can forget about this negative over here because area can't be negative. As long as you've done the maths correctly, this negative won't do anything. This is the right answer, so just rewrite it. So the area R, if I rewrite it up here with a different color, R is equal to 125 over 6, or alternatively 25 over 6 if you want to give it like this. And that's it. That is how to find the area between equations of a straight line and a curve.